Hello everyone, greetings to all the boat builders, multi-hull sailors, and aspiring Epicureans. I'm standing here behind the aft crossbeam here on the 38-foot void plague trimaran Epicurus, and finally having a decent look at a repair that was demanding my attention over 5 years ago. This was an issue that should have been addressed a long time ago, long before anything else. The upper connective structure, that the deck consists of in various areas, has needed some serious attention, and we'll go into that in a little bit of detail here. But fortunately, I've been able to salvage a considerable amount of wood here from a few demolished houses and set up some scaffolding and sneak in under what is a decent cover in this tent for the time being. And we're going to go up here and have a look at some issues that are prevalent in the upper portion of this beam, and some of them are derived from deviations from the designer's specifications, and some of them are from neglect and improper maintenance, poor construction practices, all of the above. So before I get off on a rant here, let's just go up and just to verify what we're looking at here. Here's the main hull, the vaca, and the Yaka's cross beams, connectives, whichever terminology you prefer. And there's the starboard ama. There's the starboard ama, and we're going to go up here and have a look. Now, whenever I purchased this boat, I took it on faith, which was an incredible mistake, serious mistake, that the repairmen, so-called professionals in the Philippines, knew what they were doing and were trustworthy. And the fact of the matter is, no one in the Philippines is trustworthy. If you go to PI and do well there, either you're really good at twisting arms and greasing palms, or you're out and broke. So I left and took what was left of the boat with me. Now, I didn't know much about ply epoxy construction, global torsion, material properties, and specifically I knew almost nothing about resins. I knew little of the differences between polyester resin and vinyl ester resin, epoxy resin, and the fact that they are the polyesters and the epoxies are not chemically compatible, in that the polyester cannot be applied over epoxy and bond to it successfully. It does not matter how much the surface is abraded. You can sand all day, but until you get down to bare wood, you're not going to get a bond. And with polyester resin, the bond that you'll get will be mediocre at best. It is not an adhesive. It is, I want to say a monomer, but it's really not. It's a single-use material. It's not intended really to bond things together. It's intended to be used as a casting material to fill fiberglass for an initial layup of a hull in one shot with no secondary bonding. Now, why is all of this important? Really simple. Knowing the differences between the resins and their properties, and really anyone who's involved with wood and as far as I'm concerned, any boat should just steer clear of polyester resin completely. You'll spend 2 or 3 times as much on epoxy. Yes, that's noted. I get that. I'm not oblivious to that. Here in Japan, I've shelled out almost $100 for a quart of epoxy hardener, so I feel your pain. However, considering the tremendous investment in all the other materials, the other 60% of the materials involved, whether they be reinforcements or lumber, it's worth that little extra bit in comparison, to go ahead and get epoxy resin and use it. Now, here's an example of what happens whenever you try to put polyester resin down on epoxy. Whenever I hired the guys to do the repairs, I paid them the extra change, contacted ATL Composites, put in an order for West System epoxy. They took the money that I paid for the resin and delivered polyester. And I didn't know any different until I got there, and it was already too late. I arrived, I had 15 gallons of styronated resin sitting on the docks, and another 10 gallons had already been applied to the boat. And what you see is a product of using polyester. It's crap, folks. It is permeable. It spends its entire life soaking up water and breaking down, trying to return to its organic state. It is solidified through a catalytic reaction that involves methylethyl ketone peroxide, where the curing process is giving off water vapor. So it's constantly, throughout its lifespan, trying to draw that water vapor back in, and it does. So it permeates through the resin, hits the epoxy, and that's where things start to separate. That, in addition to the chemical incompatibility of the epoxy and the polyester, they do not bond. So you can see these sheets of material, they're just completely coming off. And what's underneath is just disgraceful. You see a 6-ounce glass cloth that's been abraded into from careless workers who really are probably having a beer right now and patting each other on the back for the money they got out of me. But to go here into a bit more important detail in the grand scheme of things, looking at this beam, you can see 1, 2, 3 lockers, and to the casual onlooker, this would seem like a great thing. Yeah, you've got lots of storage. Woohoo! No problem. Get in and out of them. The problem is that these are way, way, way too large, and the designer specified a much smaller opening for a Danforth 12H anchor for a wet locker on both sides that is heavily glassed and properly maintained. And as you can see, of course, these were not. And not only are the openings much larger beyond the specified engineered limits of the design, but they also have sharp corners, which causes a stress concentration at each point. So naturally, you're going to have cracks. The upper fairing on this aft connective is the most highly stressed portion of this whole beam. The compression loads up here at the top are quite high, so any area where you can have a stress concentration, the global torsion imposed on this whole structure is going to concentrate in that corner, and that's why you get these cracks. You can see this whole remaining web of material in here has completely and totally failed. The edges were never properly capped with glass. They should be very heavily, at least 2 layers of 6-ounce cloth, and preferably these edges should be pushed back with a chamfering bit and built up with some bog, some silica filled bog to toughen them. Now moving on here, because of the lack of edge treatment and sealing on this plywood, you can see the moisture permeated in and just went everywhere. We have another crack over there where there was a stress concentration. We have a crack here where there was a stress concentration. I goobered it up with some crap when I was in the water. Don't ever let anybody tell you you can get repairs done in the water. You can't. You'll waste your time. Pull your hair out. That's why I'm going bald. All right, moving on to design deviation and construction flaw number 2 here. In addition to putting oversized openings in these beams with square corners, adding insult to injury, the builder put a goddamn glass drain tube right here and encroached upon this plywood skin on the upper structure. And of course, wonder of all wonders, the cracks have progressed out across here. These are the kind of problems that all accumulate and cause major beam failures at sea. It is very, very important to me to get this out to everybody that I can, because this is how these boats break apart. Now, moving on here, there are some other issues that should definitely be addressed. This aft section is a buried ladder truss main strength bulkhead. It's a sandwich between this outer layer, which consists of a piece I scarfed together layer of 9mm plywood, and the inner layer, which is another 9mm layer of plywood. There are diagonally positioned blocks of wood, along with pieces of lumber stringers, for lack of a better term, that run across in between these 2 layers, and they have been assembled with screws, the heads of which have heaved up a little bit in a few places. But more importantly, what I want to point out here is the builder has installed hardware directly over this main strength bulkhead, and it's the type of hardware that is permanently bonded in. These U-bolts are fixed. They cannot be removed, and the epoxy annuli that are in the holes that they're bedded into cannot be inspected for cracks or watertight integrity. This is dangerous, folks, because you can have, as you can see here, you can have a delta load that will bend this metal attachment point, causing it to deflect and possibly cracking that epoxy annuli in there if the material is somewhat brittle. If the builder used, say, West System 105, a very, very hard, stiff epoxy without any fillers, that annuli could have cracked and there could be water incursion going down to the beam. The only way to find this out is to cut these out and have a look inside. Take a sample, take a moisture meter, check the moisture level, stick it in an oven. Come back the next day, check the moisture level again. If you see a dramatic difference of over 10%, after that time, there's a pretty good guarantee that your toothpick here has gotten wet and its strength has been compromised. So these are coming out. There will be no metal fittings penetrating the deck in this area at all. And the only fitting that will be penetrating the deck will be the mooring cleats positioned on the outer ends of the beam, of course, and those have to have backing plates. They have to have heavy epoxy annuli. They have to be well bedded in, and they are inspectable. I can climb down the AMA here, get in there with a flashlight, look underneath, and if there's any water incursion at all, I will know. I can check the annuli, check their condition, take the hardware out and service the through holes with some polysulfide caulk. The epoxy, unfortunately, protects the wood extremely well. However, the hardware should be pulled out on an annual or biannual basis. depending on how concerned you are. Check for cracks and corrosion and replace and rebed it with some polysulfide. It's a simple job, but good annuli will still continue to protect the wood nonetheless. So this is 2020. The day of hardware has come and gone. The day of stainless steel rigging wire has come and gone, and fortunately Satan has been cast back into the abyss and stainless is out, as it should be, and we're back to fiber attachment just like in the days of old. But today we have unidirectional glass and spectra. So all these attachment points are going to be replaced by composite chain plates that are going to run down the back of the hull here, and there will be no dissimilar material penetrating through the deck that can allow moisture to get in. And these chain plates are going to be pieces of small 1-inch diameter, surprisingly affordable grade 5 titanium tubing wrapped with unidirectional glass, to which I will attach Spectra soft shackles, and they do not corrode, unlike stainless steel, which suffers from oxygen deprivation whenever it's sheathed with fiberglass and buried in epoxy, and then goes bang in the middle of the night before you don't wake up. Titanium will not. It will continue to last, and purchasing it in relatively small quantities has become far, far, far more economical today than it was 10 or 15 years ago. So just keep that in mind. Furthermore, these chain plates, I'm going to consult the designer and look at the required bonding area necessary to use one of these attachment points as a lifting point for this boat. Having to go out and buy a couple hundred pounds of steel and rent a stick welder to weld up a lifting die so this thing can be lifted properly under the beams, which are the most rugged part of its structure, and not under the hull, is absolutely paramount. These hulls are not they're not weak against global loads like force, day tension, and water pressure. They're fantastically strong and incredibly light for that given strength. However, they are not and should not be subjected to the kind of repetitive point loads that lifting slings can impose through repeated haul outs. Besides, I don't want anything touching the bottom of my hull except water. So we're gonna investigate and see if we can get some composite attachment points on these beams for lifting. That may involve installing bulkheads in the forward, connectives to facilitate that so we don't get a peel load. We want the sling to be pulling inward, and in order to do that, I'm going to have to mount a bulkhead, an internal bulkhead, so that the fibers are bonded to a vertical surface on the side opposing the direction of pull. Alright folks, I'm about to sink my teeth into the top of this aft connective here and get rid of all of this crap polyester resin. I've been seeing pink for way too long, and having grown up under a matriarch who was a cosmetic salesman, I don't even want to hear the word Mary Kay, or let alone see anything that even reminds me of it. And every time I come up here, it's a kick in the balls, and I'm really looking forward to getting rid of all of this crap polyester and repairing this section of deck. So we'll be posting some updates here as we go along, and I look forward to sharing this as much information with anyone who is interested in the engineering aspects of multi-hulls and wants to stay alive out there in the ocean while they're sailing. So until next time, good luck with all your projects, and we'll be pulling for you here.